Okay, we are going to continue our notes from today where we talked about exponential equations, and we are going to talk about logarithmic equations, so equations that are logarithms. I am going to make the point when we solve logarithmic equations, you need to check for extraneous solutions. Remember, we restricted that domain. Our x has to be greater than or equal to 0. In that log base b of x, that x has to be greater than, not or equal to, sorry, just greater than or greater than 0. So I can't take the logarithm if this part of it is negative. So I always need to check for that. And we're going to start with logarithmic if you have a log on both sides. So our equality rule that we talked about yesterday is how we're going to solve this example 3. On this, I have a log on both sides. So my equality rule says that this has to equal this. And again, I'm going to make the point. I am not dividing by log. That's ridiculous. That's gobbledygook. It's nonsense. It doesn't make sense. I am simply using my equality rule that says if log m equals log n, then m equals n. And then I can quickly solve this, subtracting 5a from both sides. I don't know why I subtracted 5a. I should have subtracted 4a, but since I've done it, I'm going to go ahead and go with it. And subtracting 7. So negative a equals negative 12. So a equals 12. Now again, I need to check. I need to do 4 times 12 plus 7. That's obviously going to be positive. And 5 times 12 minus 5, that's going to be positive. So I'm good on the extraneous. Those are both going to be positive, so I'm okay with that. In fact, they should be equal, right? They should be equal. Now, if we don't have a logarithm on both sides, then we're going to have to use a different method because our equality rule only works if I have a logarithm on both sides. I don't know what's going on with my computer here. That's okay. We'll just keep going. All right, so if you only have logarithms on one side, so see here how I only have this one logarithm, I'm going to rewrite it. I'm going to isolate it. I'm going to get it by itself, and then I'm going to rewrite as an exponential. So I'm going to take this, and I am going to add 6 to both sides. That is me isolating the logarithm. And then now I'm going to rewrite it as an exponential. So remember my base here is 10. If it doesn't say it, it's understood to be a 10. So I'm going to go 10 to the 1, 10 to the negative 1, sorry, equals 6v. And then 10 to the negative 1 means 1 over 10. And then rather than saying divide by 6, you know what I'm going to say? I am going to say times 1 over 6. You know why? It'll make this side easier. So v equals 1 over 60. I could have divided by 6. It would have just been uglier. So that is our example 4. I'm going to make it so we can see the whole thing here. There we go. Again, I should check and just make sure that that part that's in your logarithm, that's 6v from right there, from right here. I want to make sure that that part is positive. So 6 times 1 over 60, yeah, we're good. I mean, really, I could check the whole thing if I wanted to. But as long as that's not negative, it's not extraneous. It might be still wrong if I did something wrong, but it's not extraneous. Okay, last example. This will be a short video for a change. Sometimes you're going to need to condense the logarithms first. So taking a look at example 5 here, I'm not able to do anything as is. I can't rewrite this as an exponential. I can't just drop the logs because I don't have it on both sides. But what I can do is use my product property here to do x times x plus 6. That's my product property since it was addition. And then I can rewrite as an exponential. 4 to the 2 equals x times x plus 2. Sorry, x plus 6. And that's going to be a quadratic, so I'm going to need to get this into standard form. So 4 squared is 16. Distributing my x, subtracting 16 from both sides. And then, yeah, I got a factor. Well, I either need to factor or I need to use the quadratic formula. But multiplies to negative 16, adds to 6. So how about, I was going to say 2 and 8, but that doesn't, oh yeah, 2 and 8, that does work. Negative 2 and a positive 8. And it's shortcut. So then I've got two things multiplied together to give me 0. So one or the other is 0. Adding 2. Subtracting 8. Ooh, I did that kind of fast. Let me give you a second with the whole page showing. Maybe. There we go. I still need to check. I still need to check. If I plug in 2, I'm going to get an 8 there and a positive 2 there, so that's okay. If I plug in negative 8, look what happens. If I plug in negative 8 right here, you see what happens? That's going to give me a negative. No! So this one is extraneous. So it's not an answer. So I only have one answer here, x equals 2. That's my only answer. And that is it for solving logarithms. Obviously, that's not it. There's going to be a lot of other things that you come across, but these skills put together in some way, shape, or form are going to be what you need in order to solve.